So we know that when more solvent is added to a solution, the solution is going to become more diluted and its concentration will be reduced. The idea of making diluted solutions and performing dilutions is something that's really important to lots of areas of life, not just chemistry. Um, like they dilute chemicals in the auto shop. You have to dilute cleaners in your house. You want to make sure that you have the right concentration. So we'll look at one example problem about how to use the dilution formula. So we're told that a solution of 2.58 molars of nitric acid is used to make a diluted solution. 78 milliliters of this acid is used in order to make 400 milliliters of a final solution. What is the concentration of the final diluted solution? Now, if we really wanted to, we could spend the time to try and find the number of moles and then do C equals N over V for both, and you may still arrive at the correct answer doing that, but we can make this a lot easier on ourselves by using the dilution formula CI/VI equals CF/VF. Where I equals initial and F equals final. So knowing that, let's go back into the question and extract the relevant information so that we can solve it really simply. So the initial concentration is 2.58 molars or moles per liter. The initial volume is 0.078 liters. Again, we were given 78 mils, but we cannot use milliliters. We cannot use milliliters in molarity calculations. You must convert it into liters because remember, molarity equals moles per liter. Right? Liter, liter, liter. So we have the initial concentration and the initial volume. And then the final concentration, that's what we're being asked for, so it's our unknown. And then the final volume is 0.4 liters. 400 milliliters divided by 1,000 equals 0.4. Alright, so now we can begin to solve. CI/VI equals CF/VF. And we want to isolate CF on its own so that we can solve for it. The way that I'm going to do that is by dividing both sides of the equation by VF. That allows us to cancel out VF on the right side of the equation because VF is it's the same. Anything divided by itself is 1. So that means that CF will be equal to CI/VI over VF. And then we will plug in our information back from our data list. So that would be 2.58 molars times 0.078 liters divided by 0.4 liters. And then when you type that into your calculator, you are going to get something around 0.5031 molar, or just approximately 0.50 molar. And that is our final answer there. Then we'll just write a nice therefore statement. Therefore, the concentration of the diluted solution is 0.50 molars. So just to recap what we did, We identified our relevant equation up here, CIVI equals CFVF. If you see the words diluted or initial and final concentration, you should think to use that formula. We extracted all of the relevant information from the problem in a data list, making sure to convert the volumes into units of liters because we cannot use milliliters in molarity calculations. Then we rearranged our relevant formula using algebra to isolate the variable that we wanted to solve for. Then we plugged in our data to result in our final answer of 0.50 molars. So that is how you would approach a dilution problem.